Okay, next one is factors favorable for the formation of ionic bond. So here already said in the formation of ionic bond, which one is involves? Formation of cation, formation of anion. Okay, now here factors favorable. Which factors favorable for the cation and which factors are favorable for the anions? So here majorly three factors favorable for the formation of cations. First factor is low ionization energy. Low ionization energy. So once observed in this, I am taking one example, potassium and sodium. In this one, potassium is having low ionization enthalpy when compared to the sodium. So once observed, these two belongs to first A group elements. So top to bottom, what happens? Ionization energy is decreases. So here that indicates what? Potassium is having low ionization energy when compared to the sodium, and that potassium ionization energy nearly is 495 kilojoules per moles, and whereas sodium ionization energy is nearly 515, nearly as I am saying 515 here. So which one is having more ionization energy? Sodium. And here observe, based on this, the atoms which are having a low ionization energy, which can form cations very easily. Okay. Then next one is large. Next factor is large atomic size. So here I am taking an example. Lithium, sodium, potassium, rubidium and cesium. These all belongs to same group elements, that is first A group elements. And in that one, what happened? Lithium to cesium size is increases. So the bigger one is easily forms cations. Bigger one is who here? Cesium, and smaller one is lithium. Smaller one is lithium. So here what happened? The atoms which are having large atomic size. Large atomic size. What happens? A large atomic size is means when size is increases, the nuclear force of attraction is decreases and valency electrons. So that is capable to form the cations. Okay. Now third condition is low charge on ions. So here once observed charge, sodium +1, magnesium +2, aluminium is +3. So sodium +1, magnesium +2 and aluminium is +3. Which one is having low charge? Which ion? Sodium is having low charge. So here charge is what happen when charge is increases? When charge is increases, the size is decreases. That means nuclear force attraction is very high on valency electrons. So sodium ion easily formed when compared to the aluminium +3 ion. Okay. So these are favorable conditions for cation. One more condition also there, that is fourth one. Inert gas configuration. So here observed Ca+2 and Zn+2. In these two cation, which one is here favorable? Which one is easily forms? Here the calcium, already you know their electronic configuration. Calcium electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. So here while last two electrons it gets inert gas configuration, that is 3s2 3p6, that means 8 electrons present. We have, okay, and whereas in zinc observed here, zinc electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. When zinc is converted into Zn plus 2, so it possessing 3s2, 3p6, 3d10 configuration, and once observed here valency shell is 3. In that one we have 18 electrons. Here 8 electrons. 8 electrons means inert gas, whereas 18 electrons means pseudo inert gas. So here the cation which having inert gas configuration, that is favorable. The cation which does not having inert gas, that is the inert gas not having inert gas configuration, that is not inert, that is octet. Okay. So here this is pseudo octet configuration. So in this one, which one is cation easily formed? Ca plus 2. Then inert gas configuration I am changing, octet configuration. Octet configuration. Okay. So the cation which having octet configuration is more favorable for cation formation. The next one is formation of anion. So in that one, here the elements which having high electronegativity or electron gain enthalpy. I think you know electron gain enthalpy means what? Electron affinity. Okay. So in this one, fluorine, oxygen and nitrogen, in that one is fluorine having the highest electronegativity value. Then it is easily forms anion. Easily forms anions. The atoms which having the high electronegativity nature, then it easily forms anions. And best example this one. And a small atomic size, it is quietly reverse to the large atomic size of cation. So the anion which having smaller in size, that one is the atomic size. So fluorine, chlorine, bromine, iodine. In these four atoms, which one is having a small size of fluorine? Then it is easily converted into fluoride ions. So fluoride ion easily formed when compared to the chloride ion and the bromide ion and iodide ion. Okay. Then low charge on ions. So here once observed here, -1, -2, -3. The charge value is increases, the formation capacity of anion is decreases. So -1, -2, -3 values increases, then it is formation of anion is less. So these are factors favorable condition for ionic bond formation. Okay. Next one is properties of ionic bond. So here first property is physical state. Physical state. Ionic compounds is generally hard. And they are crystalline solids. Crystalline solid. Second property is solubility, that is dissolving nature. Already you know solubility favorite condition is like dissolves dissolves like. So here once observed that one, here the ionic compound is having polar in nature. That means ionic compounds are polar in nature, means the polar compounds are dissolved in polar solvents. So here ionic compounds And here solubility condition. This condition is very important. Solubility condition. Solubility is directly proportional to dielectric constant, and one more condition is solubility is also depends on lattice energy. So dielectric solubility depends on both two conditions. One is dielectric constant, another one is lattice energy. Dielectric constant value increases, the solubility also increases, and solubility, whereas lattice energy is increases, solubility is decreases. So the next one is third one is NP and BP. That is what? Melting points and boiling points. So here melting points and boiling points of ionic compounds is very high. So why it is high? Due to strong electrostatic attraction. So that's why ionic compounds are having high melting points and high boiling points. Then electrical conductivity. Fourth property is electrical conductivity. So here generally most of the students know ionic compounds are good electrical conductors. So but in which physical state they are acting as a good conductors. So ionic compounds which are present in aqueous state, then only they are electrically good conductors. But whereas that ionic compounds present in solid states, they are act as bad conductors. So here remember ionic compounds. Good electrical conductors in aqueous state, but not in solid. So now in this condition, once remember NaCl solid and NaCl aqueous. Now once say which one is a good conductor. NaCl aqueous is a good conductor. NaCl solid is a bad conductor because it is present in solid state. S indicates solid and AQ indicates aqueous state. Aqueous state. So remember this one is very important condition. And fifth one, isomerism. Here ionic compounds are not exist, does not shows isomerism because they are non-directional. Because they are non-directional. Isomerism is not exhibit. Which one? Ionic compounds are not exhibits isomerism. This one is fifth factor. Okay. Next, sixth one is isomorphism. Isomorphism means generally the two ionic compounds which having same electronic configuration in their ions. So here first condition is first statement is ionic compounds shows isomorphism. What is meant by isomorphism? Isomorphism means what? Two ionic compounds shows same electronic configuration in their ions. So that is isomorphism. So for that I am taking one example. First example, NaCl and MgCl2. Here in NaCl, which one is cation? Na plus sodium is a cation and anion is chlorine. And already you know electronic configuration 1s2, 2s2 to p6, and that is what 2,6, and here 2, 8, 8, and whereas in this MgCl2 once observed, magnesium is a cation and chlorine is a anion, and magnesium configuration 2, 8, chloride ion configuration 2, 8, 8. So in these two compounds once observed, cation and anions both are having same electronic configurations. I am giving one example for you. You practice it. Second example is CaCl2 and K2S. You can think these two ionic compounds are these two compounds are exhibit isomorphism or not. Okay, these are some properties, some important properties of ionic compounds. Okay.